Hello everyone, welcome to your next section. In this one we are going to actually do some statistical analysis using natural language processing. So we introed a little bit of sentiment analysis to you, but we're also going to now do a little bit more with some calculations and statistics with sentiment analysis. And we're going to learn about something called a TF-IDF score. So this is a way of trying to link in chapter 6 with this chapter, showing you a new package called scikit-learn, which is what we use to do our machine learning with. So you're going to be introduced to that package, and hopefully over the course of this section you'll be introduced to it enough that you can learn about how to use sklearn for other things. And then maybe we'll use it a little bit in a demo in chapter 10 for some sort of machine learning analysis. Okay guys, so what you're going to learn today is you're going to learn again some of that sentiment analysis stuff. I'm going to show you how the sentiment analyzer works one more time so that we play with it a little bit more, just to remind you. And then we are going to go into TF-IDF, which is this way of calculating a value for a document that's used a lot of time in linguistics and natural language processing. And we're going to do all that using scikit-learn. So what are our definitions today? We talked about sentiment analysis a little bit. We used that Vader tool. I just kind of showed it to you really quickly where we could get some sort of valence metric or out of a piece of text using Vader, which is a sentiment analyzer algorithm that you can read more about. Their code is open source, so it's pretty easy to read. And sentiment analysis is like an algorithm that can take a piece of text and determine its emotion. We're talking positive, negative, neutral, and compound with Vader, but people are trying to do this with all different types of emotions, like doing 12 classes, how happy, sad, disgusted, you name it. So this is a really nascent and budding area because Python is so useful and easy to build these kind of algorithms with. So it's a really cool area, and I highly recommend that you learn more about sentiment analysis in general because you'll probably learn something about yourself and the way that you talk, which is interesting, or at least right. Anyway, the next thing is TF-IDF. This is called Term Frequency Independent Document Frequency. It's a calculation that counts all of the unique words in a piece of text and then basically does a very easy math calculation, takes the amount of times any word has occurred in that document and divides them from each other essentially. And what that does is it gives you a word novelty score. And if you calculate a word novelty score multiple times and then take an average of it, you can get kind of a general novelty of that document. And this is where we can start to intersect some ideas from machine learning into a process like this. For instance, thinking about your independent document frequency, like how much is in your corpus, would be a proxy for training in machine learning. We'll spend a little bit more time talking about this when we hop into the code and the syntax. So for now, just think of TF-IDF as just a number that kind of gives you some sort of word novelty score. And it can also give you specific word novelty scores, like this word is very unique in the body of text as opposed to this one as well. So let's move into the syntax of this and see what we got going on here. So first things first, some of this stuff is familiar to you. You probably recognize these two lines here. This is our Vader sentiment analyzer and our NLTK corpus that has our Shakespeare and Macbeth in there. And then, so make sure that you go into Anacondas and install and download scikit-learn. It's this here, sklearn. And we are going to import these two functions, the TF-IDF vectorizer and the normalize function, okay? So remember from last time, we had this function here, which is a noise remover. We removed words that we have lots of common occurrences of. I kind of changed this one to the so we can see what's going on with that. And we had this thing called list comprehensions here, which is very interesting and unique to look at. So I'm going to show you another list comprehension down somewhere else so we can see an example of that in what we're doing already. Then we had, it removes the words. It then turns the list back into a string separated by one space, and then returns that text, which you then catch when you run the remove noise function. Okay, so in this line we load up the Shakespeare plays. This time we get the raw file, and if you look at the text, most lines are split by double line break. So I'm saying that each of these lines of in this raw file is going to be like a sentence, or at least a section of text that we want to look at. Okay, and then I created a list comprehension here. So this split created a list, and then what I did was, for each piece of text, I ran our remove noise function to remove all of the extra words, okay? So I created a list comprehension with no if condition. This is just the syntax for it, and it's all wrapped within square braces, okay? Then I created our sentiment analysis object, and I commented this out, but we did this before, where we, we looked at the sentiment analysis of this, of a piece of text and played with it a little bit. So we'll do that one more time, and you'll see what we can play a little bit more with it and see what's going on with it. We can add a couple other things. In this next set of lines, this is where we're going to calculate our TF and IDF, our TF-IDF calculation. So first, we create vectors, and we create n-gram vectors for this TF-IDF. So it's going to calculate on n-grams, and then we transform this information into basically a list of lists, all right? Or actually, it might be a data frame. Let's look at this when we pull it up, and we'll see exactly what the object type is. And this line just gets the names of each of the features that it vectorized from, and we'll play with that as well, okay? So we can then look at each document here. I create a document parameter, but then we can look through each document. We get the index, so we can find where that document is in the piece of text. And then we can calculate the TF-IDF score of that specific document. That's what we're doing here. We're doing a list comprehension right here. And then we have an index. So this creates like each line of text, and this line is the index number for it. So we give it 1, 2, 3, 4, the index number, and then we give it the lines that those indexes represent. Okay? And then lastly, we print the results, and that's what's going on here. Okay, so we're going to actually play with this code now that I've spent a time just like going line by line what's going on in this code. And so if we interact with it a little more, maybe it'll make a bit more sense. Alright guys, here we are in our coding section. So first we import some functions. We go and get our corpus. We go get our sentiment analyzer, because I'm going to spend a little bit more time with that, show you that a little bit more. I wanted to kind of mix it in with this chapter a little bit to both like get you excited for it in that one and, you know, make it more interesting in this one. So then we're also, remember to, in Anaconda, install your scikit-learn package, sklearn here. This is a package that we use for machine learning, guys. So if you look at the documentation for this, you can start to learn maybe how you can do some machine learning of your own, which we're going to talk about in our next chapter anyways. But there is natural language processing statistical analysis packages in scikit-learn because the thing is so useful. We have our function here that we built, our remove noise function. It takes in an input text parameter, so we do have to give it a piece of text. We have a noise list here, so like words that we want to remove. We then split our text into a list of words, which is the default for split is for a space. So this is going to get every word and every, basically every word in every space. We then do a list comprehension here, a simple one. We go for all of the words in that word list. If it's not in the word list, then put it in the list. And we just put word like that there, and that will add it to our list comprehension. We don't print it, we just put it there. We can have else statements as well, but look at the documentation for that if you're interested at the moment. Once we have that check done, we still have a list of words. We then convert that list of words back into a string that's separated by spaces. Next thing we do is we don't need this anymore, so we can remove that. We load our raw text of Shakespeare into an object, and then we do the same split technique on this piece of text. Now remember that .raw made the Macbeth object just a straight up string. And one thing that I noticed when I was looking through it is that big pieces of text were usually separated by 2 line breaks. So I'm taking like chunks of text and turning that all into a list. So each element of that list is a big chunk of text. And so when we split that and print, let's just print like the first, 10 or something like that and see what comes up. So there you go. So this is our first thing. It's the title. We have a line break even in there, but we still have, you know, the first act, first scene, and it starts to break down. So this is probably an easier representation of the text that we'd want to actually do analysis with. So what we can do now is go through all of our text. Let's actually look at how many different lines there are, how many different like pieces of text there are, just out of curiosity. So we're going to use the length function on our list, and it's going to tell us how much is in there. There we go. Double parentheses because it closes the length function and then it closes the print function. So we have about 680 different chunks of text here that we're going to analyze and do really quickly. So we're going to do our list comprehension one more time, but this time we're going to do it using our function that we built. So in this case, we have a very simple for loop. There's no conditional statement, so we're just going to do for each thing. We're going to have it return the output of this function, which is removing words from the list. And I'm actually going to take out the for now because I want to show you how some of our calculations might change later. So okay, with that, we're going to save that, and then we're going to print this really quickly, or at least print a couple of lines of this. We might not see any difference, but it'll still be good to see. 10. Oh, how did I screw up the syntax here? Oh, we had this extra one here. Silly me. And then we can close that. There we go. And we might see some, like, yeah, it might not be apparent to see, but it did pass through and it works just fine now. Okay, we can remove, let's just remove Actus, and just so you can see this word, Actus. There you go. And Actus is gone now from there. Okay, I'm going to remove that and continue to play. So one thing we're going to do before we hop into doing TF-IDF is I'm going to show you sentiment analysis a little bit more. We're going to play a little bit more with this analyzer just so you can, both as a reprieve and as a way to kind of like play with this a little bit more. So I want to show you other features that this can do. It can, oh, let's stop that print. So the sentiment analyzers can also handle emoticons. So this knows that this is a happy face, so it's you know, scoring it as positive and giving it a compound value of this, which means compound value is, I believe, it kind of floats between 1 and -1, and it's a little bit more of a, it's a more complex calculation, meaning that, you know, like a smile doesn't always necessarily mean it's a positive thing. Someone can smile in a very like nefarious, like mean way or something like that. So it's saying it's probably positive, but you can't really tell. We can do, let's try some other things like something negative. I really hate this NLP. Got that there, and let's see what it prints out. So it kind of guesses that it's negative, probably from that hate stuff. But let's see if we capitalize it, if it adds more. It does make it more negative. What happens if we give it exclamation points? Makes it more negative as well. Does it get more or less with more or less exclamation points? It does. So like, look at how flexible this is, and imagine just like passing like string upon string into this thing and calculating averages and, you know, all different other kinds of statistical techniques that you can do in an automated way when you have like hundreds of thousands of pieces of text. It's really quite amazing. So there's your sentiment analyzer one more time. Do look at the GitHub for it because it shows you everything on how you can change its library to behave in more ways that you want it to. So maybe you want it to have a dialect that is more suitable for business culture, so you can have positive, negative valence within business communications. You can build a library of words and some syntax rules that it will understand, that it will be able to compute that for you. So it's a really cool process. Okay, let's do this TF-IDF thing now. First, we're gonna, you know, vectorize. We're going to create a vectorizer, which is kind of like an object that when we pass in some parameters here that say like what we want our n-gram range to be, how we want everything to be grouped up. And then we transform a piece of text into our vectorized object. So we pass in these parameters to the object, so it now knows, you know, some initialized parameters that in order to run this fit transform function. It's going to transform our pieces of text into a vectorized values. So let's just print x and see what comes up. So we get a bunch of tuples with numbers associated with them. And so what each of these are, this here represents a specific word. And then this represents a specific like topic or index. Or no, this actually represents the document itself. So these are the words that are in each of the each document. And each of these numbers represents the TF-IDF score for that word in that n-gram analysis that it did across all pieces of text as well. It did that. It counted all the words and then did a calculation of like the term frequency in from each of those independent documents. Okay, that's what that is showing there. So it's a little bit hard to see though. So we're gonna make this a little bit easier to see and show you a couple of other features of visualizing this so you can look at specific words and what their TF-IDF scores are. So this here prints our feature names, which means all of our unique words that are in the body of text that we gave it. This is the entirety of Macbeth, and it takes out all of these special characters and words and gives you each unique individual word. And so what we can now do is look at each document and get the features for that document, get each of the words for that document, and calculate TF-IDF scores. You'll notice here, let's actually just also look at the type of X here, because it is it looks like it's using Panda's indexing syntax. So it's a matrix in SciPy, which means basically like our Pandas data frames are basically matrices, and it's a simple way of like manipulating CSV data like their matrices. So SciPy is doing almost the exact same thing in that it's using the same syntax language in order to index a matrix, which is, you know, basically just think of it like a CSV. It's got X and Y, and it's got, think of it like a data frame. That's really what it's going to be like mostly for you. It takes all the non-zero values and like the first feature value for each of them. And then we get the scores for all of these values by doing a list comprehension in here. So it gives a list with each of the document and the words for that document, and then puts it all together, and we get the name of the word as well as the score for that word, and then we just print it all. Basically, we do one more list comprehension here, which is we get the names for all of our, remember how we had the tuples that were 0 and 168? It ends up giving us the names for all of these things when we print it. So we picked one specific document, like the document 21 from my split of this double line break, and the King Rose God So. So this is a line of Macbeth, and it's giving the TF-IDF values for each of these words in this particular document. Okay, so you can do a bunch of other stuff, play around with this, and see how it all works, guys. Okay, so with that, I think we're going to close it. What did we learn today? We learned about scikit-learn, so we imported that package. We spent a lot of time with list comprehensions again. I showed you a little bit more of sentiment analysis because it's a really interesting thing to see and like play a little bit more with. And we did TF-IDF calculations with lots of list comprehensions built in there. You got to see like how matrices and data frames are similar and how you use similar indexing syntax across many of these different things. So with that, guys, thank you very much, and talk to you next time.